Okay, so this is section 5.4, and we're going to talk about this idea called completing the square. So in here it states that we're completing the square, which is a process which you can force a quadratic expression to factor. So the idea is some quadratic expressions can't factor. So for example, if I have x squared plus 3x plus 7, we generally say what two numbers multiply to 7 but add to 3. No such numbers exist. Well, they do exist, but they're just not nice numbers. So we use this idea of completing the square to make this an expression that we can factor. Okay, so we're going to go ahead and we're going to start with some examples here. But before we do that, one of the vocab words that we're going to discuss, and we'll actually just go to the next slide, is, well, actually before we do that, what I want to talk about is what we're doing still. So if we had an expression x squared plus 3x, excuse me, let's change this. X squared plus 5x plus 6, we would factor to x plus 3, x plus 2, and we would find what are called our zeros or our x-intercepts. Okay, so these guys are, this is synonymous, zeros or x-intercepts. Okay, so we're finding those. So when we're completing the square, we're doing the same thing. We're finding these, but we're not just manipulating the equation. So based on what's given to us, we use this completing the square process, and we're still finding the same stuff, zeros, x-intercepts. It's the same thing we're finding when we're factoring that we have. So we have this complete the square for each quadratic expression to form a perfect square trinomial. And so what we're going to do here is, well, we want to make this a perfect square trinomial. So that means that in order for this to be a perfect square trinomial, we're going to have two terms multiplied together that are the same. And so I'm going to tell you what these are. I'm going to tell you what the factor is before I tell you how to complete the square. So if I look at this example here, x minus 5 times x minus 5, this is going to be or create a perfect square trinomial. So if I factor this, it's going to be x squared minus 10x, right? That's our first piece. And then I multiply these last two terms, and I get 25. So what number needs to be added in here in order to make it a perfect square trinomial? Well, this 25 is what the number needs to be in order for it to be a perfect square trinomial. So how do we get that? Well, look at the relationship between 10 and 5. 10 is twice 5. So if I create another one before we talk about the next example, if I look at x squared plus 4x, what does this last number need to be in order to create a perfect square trinomial? Well, I'm going to tell you again, it's x plus 2 times x plus 2. Well, if I factor it again, I get x squared, FOIL it again, 4x plus 4. That's the number that we would need to add in to create a perfect square trinomial. So how do we get this number at the end? Well, the idea is we take that middle term, and you notice the relationship. Well, what's 5 relative to 10? 5 is half of 10. What's 2 relative to 4? It's half of 4. Well, how do we get this last number? Well, we had to multiply these two guys together, the 2 and the 2. So in order to get the next term, what we do is we take the middle term. So if we look at our standard quadratic, our middle term is b. So to get the term to add in, we take b, divide it by 2, and square it. That's the process that we go through to add that new number in. So before we do part B, I'm going to do one more quick example with an even number. And notice also that this number that is divided, this b, when it's divided by 2, that's the actual number that we put in our factored term. So if I have x squared plus 16x plus, well, what's that number that we're going to have to add in? Well, if I take 16 and divide it by 2, that's going to equal 8. Well, that number 8 is what's going to create my factor. And what's 8 squared? 8 squared is 64. So that's the number that I need to have in order to complete the square. So let's look at part B. This is an odd number, so we're going to deal with a fraction. So the number that I have to add in, so with this problem, I'm just completing the square. So all I'm doing is adding this last value. So what's b squared divided by 2? So, or excuse me, b divided by 2 squared. And I would just write that value in, 27 over 2 squared. What's nice about this is that when I actually look to factor something, whether it's even or odd, it's actually very easy because I know I'm going to add the 27 divided by 2 squared. That's not a nice number, but because of this relationship, I know that my factor is going to be that middle term divided by 2. So I don't even need to think about factoring. Okay? And that is how we find a perfect square trinomial. So here's a blank slide. And what's a perfect square? Well, 4 is a perfect square because the same number multiplied by itself, right, equals that number. Excuse me, two numbers multiplied together, they are the same number, equal 4. Okay? So now 4 is a perfect square. So what's a perfect square trinomial? Okay? Well, so with the perfect square trinomial, we're going to have two terms that are the same being multiplied together that are going to equal this trinomial. Now, a trinomial is an expression with three terms. So for example, if we take x squared plus 2x plus 1, let's factor this. Well, what two numbers multiply to 1 but add to 2? X plus 1 and x plus 1. This guy right here, the x squared plus 2x plus 1, is a perfect square trinomial because its factors are the same. So completing the square is within the rules, but cheating, kind of. And we create this so we can factor a term that is at first unfactorable. So let's look at the